Hello again. So this is the third lecture, and we'll be talking about a bit of ADT, stack, queue, and interface, and other ADTs like sets and sequences. So ADT allows multiple implementations. In class, we saw that stack can be implemented in array and linked list, and queue can be implemented with array, linked list, and ring buffer. So other ADTs like sets and sequences, we'll talk about it in the later slide. So in case of stack, it is last in, first out. We call it as LIFO structured. And stack has three methods like push, pop, and empty. So push is basically adding an element, and pop is removing an element. And empty basically checks whether the stack is empty or not. So the runtime for push, it is of one constant time because we just basically need to update the head pointer and add a new element to the front part of the linked list. In case of pop, we do the same thing. We remove the head and update the head to the next element. In case of empty, it actually depends because let's say you had a self.len value in the class field as we explained in a previous video. We explained that if we keep a self.len value and we do the +1 when we do push and -1 when we do pop, we can basically keep track of it with an O of 1 constant runtime. However, it will take O of n runtime, the linear runtime, in case we decided to do the iteration of the linked list and not keeping track of the size in every push and pop method. So that's basically why I said it depends. In similar, like the queue is also the similar. So the thing is, it is first in, first out. It's called FIFO structured. And there are three methods: enqueue, dequeue, and empty. So enqueue is basically adding an element that takes O of 1 constant time because we're basically adding an element to the tail. So we need to make sure that we have a self.tail value in its class field, otherwise it'll take O of n runtime because we need to iterate from the head to the last element and then add the new element at the end. In case of dequeue, it'll take O of 1 regardless of whether we have tail variable or not. So dequeue, we basically remove it from the front. So we just update the head value like what we did for the stack. In case of empty, it's same as the stack. So if we have the self.len value, the class field, class variable, we can easily do it with a constant time. However, we need to, if let's say we need to iterate through and count every element in a linked list, it'll take O of n linear runtime. So I think a lot of people got confused the interface structure. So there's a queue interface which contains the three methods that we just saw: enqueue, dequeue, and empty. And we can implement queue with different structure like linked list queue and ring buffer queue. So linked list queue class and ring buffer class are both like inherited from the queue interface. So we call it as inherited because its child class shares the same trait and methods. So this is basically why linked list queue class and ring buffer class have the same methods but implemented in a different way. So the thing is, queue interface, we only define what kind of methods will go. So in the homework 2 code, you can see that queue interface has like three methods listed down only, but then the detailed implementation was done in linked list queue and ring buffer class. So the detailed implementation should be done within the child class, but the method definition should be done in the parent class, which is the interface class. So that's the thing for the interface. So if you get confused of interface, probably refer to the 100 level course, or just like search up the Python interface and like how they got inherited. And yeah, this is like other ADTs. This is sets. So it's a mathematical set, basically stores unique elements without duplicates. So the methods can be like membership, like whether it's part of it or not, like insertion method and etc. It can be also like implemented with different types of data structures like array, sorted array, linked list, and others. So the sequences is ordered collection of items. So class methods can be like get or set nth element, add, remove at the start, end, like stuff. It can be also implemented with various data structures like linked lists, arrays, dynamic arrays, and etc. So this is pretty much it for the ADT, stack, queue, and stuff. So thanks for watching. I'll see you in the next video.